Hello everyone, my name is Taki and today I'm excited to share my research on using in building information modeling, BIM for environmental simulation, uh, improving sustainable design consideration in residential building. In my thesis, I covered the following main or key points: introduction to BIM and its effect in the AEC industry, the role of BIM environmental simulation of sustainable design in residential building, and I also focus on building design principles, sustainable building design principles, building envelope design, material selection, resource efficiency, indoor environmental equality. Also, I analysis of sustainable building rating system, LEED, BEER, ERG, and WELL concept. And finally, the case study using BIM for environmental building simulation in residential building design. Okay, let's explore the benefits of the importance of green building for both the environmental and occupations. Resource conservation. Green building conserve resource by utilizing eco-friendly product technology, reducing waste generation and minimize energy and water consumption. Improve well-being, this structure prioritize the health and well-being of occupants, leading to enhanced productivity, better focus, and overall improving well-being, marketability and value, and social responsibility. Here, importance of energy modeling for improving building energy. First of all, optimizing efficiency. It helps us make infrastructure and space super efficient. Impact assessments. Energy modeling, check how our design choices affect energy use. Quantify impact. It measures exactly how those choices affect energy consumption, guiding us to make things better. Exploring strategies. It explores many strategies to use less energy in building. Okay, here some of sustainable building design principles: biomemory, human vitality, ecosystem harmony, seven generation, conservation, holistic approach. Okay, now let's talk about this system that help us build more responsibly and sustainably. Each highlights a specific part. Many of them also share a common points. Like here, we highlighted LEED and WELL concept. On the other hand, we quickly reviewed BEER and EG, where EG identified cost efficiency strategy for reducing energy, water use, and embodied energy in building material. On the other hand, here evaluate power system performance and infrastructure to promote resilience. So resilience and sustainable practice in the utility sector. The project that we worked on consists of residential tower, some of which are existing and some are under construction. Therefore, we have studied each of LEED and C, LEED BD plus C, and LEED for existing building operation and maintenance, LEED EBOM. Here, the concept of in well, that we highlight water, ensure safe water while conservation for building occupants, water conservation, light efficiency, and building envelope design and HVAC system. Let's start with the case study. Our case study was 6 towers, each total of 300 unique apartments, total area 18,000 square meter. The scope work was doing energy calculation and modeling, developing costs and scripts, placing the equipment. And here, the methodology. First, we will clarify the work methodology. The project was worked on using BIM, just native BIM using Revit, so it was necessary to use model as a bridge between the architectural model and the MEP model to host and make calculation in order to prepare the MEP model. Here we prepare the architectural file or model by entering the appropriate parameter for each architectural elements in order to make the simulation process using Dynamo faster and easier. Here we see 6 towers, each of which has a code letter that describes each tower consists of several floors. Each floor has a code indicating it, and the building it's located in. Yeah, here. Here, each tower consists of several floors. Each floor has a code indicating it, and the building it's located in. This approach is repeated throughout the apartment and the elements found in each apartment. Yeah. Here, as we see the parameters of windows, it's same for every door and floor and walls in each apartment that has code B.02.S1.2 that mention this window in the apartment 2 in the section 1 in the second floor in building B. Here we start to prepare the MEP model. So we have to move the data from room to space to use space as the host category. So create a space for all project and copies room and all data needs. This space that we don't need and copy information from room using Dynamo scripts and Python codes. Here we can see how the process works. First one is the MEP model. Second one, creating space for all project. Third one, copy the name. Third one, delete space for one, copy the parameters value. Here we prepare the model again, and as we see the space category parameters that we need to use it as a hosted parameter, like wall reference, floor reflectance, and lighting calculation, etc. Here we review the light simulation guidelines for both lean and wear that we use in the model and calculation, and which we will delve into. First, initially the guidelines test that 90% of the occupied floor space should receive at least 10 lux of daylight. It also indicates a minimum of light transmittance availability of 40% and daylight for 70% of building occupants. Illumination levels range between 150 and 500 lux. At least 50% of the regularly occupied floor space. These values are known by involving equation with the model and performing calculation. The daylight in the building is calculated and the value are verified. We noted in the figure at the bottom of the screen on the right, the vectors connected between or line connected between the point on the workplace and each of corner of and middle of the windows to calculate the daylight factor. Okay. Okay, natural lighting coming from also the sun, and its reflection can be added to this calculation by tracking the sun rays as shown in the top figure. So we calculate the radiation, and so the solar radiation, and then converting it into light through tables or through any equation. Okay. Here, this points and guidelines, it's mentioned that it's necessary to give the user the ability to control comfort by providing the space with the glare control planes shaded to comply with the minimum levels of 150 lux, allowing residents to control lighting parameters such as intensity, color, temperature, etc. Here, conduct measurement during the day between September and October from rivet sunsetting, and calculation to specific time point for the sky day at the equinox, 9 a.m. and 3 p.m. also from sunsetting. And here we, by region, take measurement of 76 millimeter above the floor for kitchen. Here we place the family in the standard range to work as a sensor to host the sunlight and daylight factor total values. Here we can see the family that placed in each space and dynamo script and the sensor parameter. Here we have begun to present the result of the calculation, where the output model represents the sunlight reflected within the indoor environment, and 2D plat present the sunny points. So we can improve the design by adding reflective surface to increase the lux among the area that needs more illumination. After completing the study of the behavior of light and improving it, we study the behavior of sun, the BIM, and the energy gain in the building. The methodology here is by determining the behavior of sunlight during the month and the exposure time of each element separately. Then study the amount of energy that the elements allowed to pass through. At the end, we find the sum of energy gain or lost during the months to determine the amount of energy that must be gained for heating and the energy that must be lost for cooling. Here we find the family, which is we use it as an alternative to the architectural elements for hosting data related to such as the orientation, the room air orientation for elements, and room area and room name. As you can see here, 3 Python codes work to determine the times within a month during which an architectural elements is exposed to direct sunlight. You can see here the Python codes to do the calculation, and here we can see the result, the energy for each ray, the maximum and the minimum and the average. So we have like 17,302 values. Now time to export this data to Excel sheet so we can read it. Here we have exported data that the first one in the top, it's as exported, below after presented. So each schedule or each table for each apartment with the data. So, and here for sorry, here about the heating system, and this is schedule for cooling system. Okay, here. He reviews some of the points that the guidelines reviewed about water. Regarding this part, it was manually work. The work is underway to make the necessary calculation related to the water conservation and install the needed equipment. Here we can see the plan view, 2D plan view for water equipment needed. As a result, here the underground air conditioning system, and finally the false ceiling air condition. And thank you